Mackie
And Luke.
here to explain basic polynomial end behavior and also how to graph them. Polynomial end behavior is basically how the line changes as it goes from negative x values across to positive x values. Now let's begin with some basics. If the term of highest degree is positive with the exponent being even, it will create a positive polynomial or positive quadratic equation. This means that both sides are pointing up on either side of the x-axis. From here, we can determine that the end behavior, you can see that as, let me change the color to show, as f of x, or as x goes to positive infinity, or as f of x goes to the right, or as x goes to the right, y, or f of x, or y, goes up. This would then show us in our equation here on the bottom that f of x, if x goes to the right, f of x goes up, which means it's also going to positive infinity. Now also vice versa, on the left side, as f of x goes to negative infinity, or to the left, the f of x, or y, also goes up. Therefore, also proving that for this part of the equation, as x goes to negative infinity, f of x also goes to positive infinity. Now for the next equation, if the coefficient right here is negative and the exponent is still even, the equation will make a quadratic equation, a negative quadratic equation with both sides point down. And then much like the other equation, when the x goes to positive infinity, or to the right, and goes to negative infinity to the left, y, or f of x, goes down. So this would mean that f of x is going to negative infinity. So for our first two equations, the end behavior would be as x goes to positive infinity or negative infinity, f of x goes to positive infinity, which is the same for all polynomials with a positive coefficient and an even exponent, as well as on the other side, it's the same for, on the other side, it's as x goes to positive infinity and as x goes to negative infinity, f of x goes to negative infinity. This is the same for every polynomial with a negative coefficient and a even exponent. Now we're going to clear and and Luke will tell you about our next one.
Okay, now what would you do if we had a positive coefficient and an exponent that was odd, so in this case 3. For this graph, it starts negative and then crosses the x-axis at 0 and goes up. So it's down in quadrant 3 and up in quadrant 1. Now as x approaches positive infinity, f of x... What?
Or to the right.
As x approaches positive infinity or goes to the right, then f of x also approaches positive infinity and goes up. Okay,
so
and then...
mean that in f of x would equal positive infinity. Just say it again.
Just say, so it's just as x approaches positive infinity, f of x also approaches positive infinity. And then also, if x is approaching negative infinity or going to the left, f of x also approaches negative infinity and goes down. So as x approaches negative infinity, f of x also approaches negative infinity. This is the same for all coefficients that are positive or odd exponent. Now do I know the second example? Okay, cool. Now what would happen if we had a negative coefficient and an odd exponent? Yeah, it's a lot like the previous one except for flipped. The graph starts positive with the arrow starting in the second quadrant before going through the x-axis, making a horizontal line, and then going down into the fourth quadrant. Now we can say as x approaches positive infinity, f of x approaches negative infinity. And on the other side, x approaches negative infinity, and f of x approaches positive infinity. That is the end behavior of a polynomial with a negative coefficient and an odd exponent. Recap. Oh, so as x approaches positive infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches positive infinity. Now I got now knowing these four basic polynomial end behaviors, we can now apply them to real problemos.
The first two equations we're going to be showing you are y equals -3 parentheses x plus 2 squared times parentheses x plus 3. Also y equals parentheses x plus 3 squared times x plus 1 in parentheses. But in order to understand these equations, you must first understand the term of highest degree. The term of highest degree is the polynomial in the highest degree of its monomial's individual terms with the zero coefficient, or in simple terms, is the value with the largest amount of exponents. In these equations, you would need to first distribute these two I'm going to do that in color. These two parentheses. However, for the sake of time, I'm going to teach you a trick in order to do these quicker. So because of these, because it's squared and that would be 1 because it's just 1, you can essentially just add these two together and you will know that the term of highest degree will be x cubed for both of them, and then all you have to worry about is then bringing down this coefficient here, and then your term of highest degree for the first equation is -3x cubed, and then your term of highest degree for the bottom equation is just x cubed. Now, knowing this and the information we had before, we know that a coefficient that is negative with an odd exponent has when x is positive infinity, it is negative infinity. F of x becomes negative infinity, and also when x is negative infinity, f of x is positive infinity. Now down to this equation, the term of highest degree is x cubed. Now, knowing from what we know, a positive coefficient with a odd exponent would give you, when x is going to positive infinity, f of x is also going to positive infinity, and also when x is going to negative infinity, f of x is going to negative infinity as well. These are two very simple ways in order to do the first two equations.
For our last equations, our first of our last equations is y equals x to the fourth, open parentheses, x plus 2, close parentheses to the second, open parentheses, x minus 3, close parentheses, cubed, open parentheses, x plus 5, close parentheses, cubed. So our term of highest degree for this one would be 4 plus 2 plus 3 plus 3, which is 12. And it is a positive, so it would be, the coefficient is positive. So that means that we have a even positive, which means it's going up. So as x approaches positive infinity, f of x also approaches positive infinity. And as x approaches negative infinity, f of x approaches positive infinity as well. Okay, second? Yeah. And then for our second equation, we have y equals negative x squared, open parentheses, negative x squared, open parentheses, x minus 3, close parentheses, cubed, open parentheses, x minus 1, close parentheses, open parentheses, x plus 2, close parentheses. So for the two parentheses without a exponent on top of them, that's the equivalent of having the exponent 1. So we can calculate that in. So 1 plus 1 plus 3 plus 2 is 7. So this is a odd and negative one, the negative coefficient. So this means as x approaches positive infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches positive infinity. All right, for our last equation, thank God, y equals x to the 7th plus 5x to the 6th. So for this one, our term of highest degree is 7, or just x to the 7, yeah, so our coefficient, and it's positive, so it's a positive odd, which means, that's right, no. So, yeah, so as x approaches positive infinity, f of x approaches positive infinity as well, and as x approaches negative infinity, f of x approaches the negative infinity. Yay!
These are our equations. Have a